Hello and welcome to this video where we'll be showing you how to set up and use a SignalTap file in Quartus version 17.1. So the circuit that we'll be using for this tutorial will be a simple counter circuit using the built-in clock of the DE2 board. The VHDL code for each of the counter modules is here. So essentially you have 3 counter modules here, and when the most significant bit of this module is at high, then it will count up when it falls down for this counter module. And then for the next counter module, it's the most significant bit of this counter module. And if you want to, you can make it more digits or not. Or you could just make it 2 digits. For this tutorial, we'll be using 3, and we'll be showing the outputs of this in SignalTap. So right now we have our circuit fully set up, we've compiled it, and we know that it's working. So we're going to go ahead and create a new file. We're going to make this a SignalTap logic analyzer file. So once we create that, we're going to want to power up our DE2 board and make sure that's connected properly. Make sure that's in run mode. You can go into your hardware setup, select your USB blaster, and there we go. We have our board popped up, everything's set up. Next we're going to want to set up our clock. So for clock, you're going to want to use the clock pin of the DE2 board. So for hours, we're going to be using the pin assigned to pin underscore Y2 of the DE2 board, which is conveniently named pin Y2. Insert it into our clock. Then we're just going to hit yes for this. Sample depth, I usually set it to 128K. That way you have more data that fits into your SignalTap file. And for that, we're pretty much done with this side over here. We can go ahead and start adding in our nodes. So for your nodes, you're going to want to change the filter settings. If your filter is not shown, your list will look like this. You're going to want to show the filter by clicking on the 2 arrows, and you're going to change the filter over to design entry all names, and then you're going to want to list. So for our design entry, we're going to want to look back to that. So here we have our design entry, so we can see our outputs are named X, Y, and Z. So we're going to take those. Then we're also going to take RD, which is our reset pin. So we're going to insert RD, and then we're going to want to insert X, Y, and Z. Here, yes, you do want to set the netlist type of .partition to source file. And you can close out of that. As you can see, all your nodes are inserted. So next thing to do is going to be to recompile and save the SignalTap file. So we're going to want to save our file as a file name. We can name it whatever we want. This one's going to be named stb2. And then we can go ahead and recompile our project with the SignalTap file inserted. Alright, so now that we're done compiling, we can go ahead and move back over to our SignalTap file and scan the chain. If you scan the chain, it'll refresh and it'll show that you either have an invalid JTAG configuration or it'll say that you need to program the board. So we're going to go back over to the main Quartus window, and we're going to go into our tools, and we're going to use our programmer. Hardware setup should already detect our DE2 board. So we'll start programming. And then once we're done programming, we can just close out of the programmer. And after that, we can go back over to our SignalTap file. If we scan the chain again, we should find that we're ready to acquire. So let's go ahead and start our acquisition. So this button over here that I just clicked will actually loop acquisition, so it'll keep on checking for new values and it'll keep on returning new values to you from the DE2 board. If you just use the run analysis button, then it will run one analysis quickly and send you back the data that came from that analysis at that point in time. I prefer to do the auto run analysis so I can see the values changing to make sure that's working properly. So we'll auto run analysis, and then we'll flip our reset pin to high. And once we do that, we'll start seeing values. So we can click to zoom in, And now what we'll do is we'll actually move the least significant bit all the way to the bottom. And then we'll move the most significant bit to the top. As you can see, they're all changing. So we're just going to stop the acquisition and freeze it at a point in time. You can see that once we roll over from 9 and we have the falling clock edge, our second most significant bit rolls over and becomes the next value that it would become. And then as soon as our second most significant bit rolls over, then we have our most significant bit rollover, which shows that our counter is working properly and our SignalTap file is showing what we want to show. So therefore you can see that you've created a fully working SignalTap file. Feel free to pause the screen at any moments that you might need, such as the block diagram or the VHDL. And that'll do it for this tutorial. Hope you learned something.